All right, hello everyone. My name is Evan. I'm going to be doing a talk about harnessing the power of Python. That's just a nicer name for, I'm going to show you some awesome, cooler features of Python that you probably don't know about and will make your code awesome. So, those are not the slides. So ignore that link for now. But we're going to cover some of these. We'll get through as many as we can. All I'm expecting from you is that you know a bit of Python, like you know how to do basic Python programming. So if you went to my last talk last semester, or you've done 204 this semester, it should be enough. And whatever you don't understand, I'll just cover, of course. All right, so what is Pythonic Python? Pythonic Python is code that is idiomatic. Idiomatic means, well, in programming, an idiom is just a way to write code. So in Python, idiomatic Python means you're writing code as Python wants you to. And we'll cover a bit more of that later. And these are things that aren't really obvious at first, but then you start to pick them up as you program more and more. Whoa, okay. So, if you import this in Python, you get this lovely bit of text. And this bit of text is what defines Python. It's a set of like standards, you could say, that Python programmers try to aim towards. So things like your code should be readable, sparse is better than dense, beautiful is better than ugly. These things should be in mind when you're writing Python code to make sure that your code is looking the best that it can be. All right. So, I'll cover some useful built-in functions to begin with, just to start us off. So, Python has a lot of built-in functions that in other programming languages you might have to do yourself. For example, Python has a min function. C doesn't. In Python, if you want to find the minimum of something, you just put into the min function, you get the value out. In C, you have to write a for loop and then go through everything and so on and so forth. So map is a useful function. What it does is it maps a function to a iterable. So if you have a list of strings and you do map int and the list, then we'll convert all the strings in the list to an int, right? So if you have something like this, what we're saying here is we go through every element in the map of int of our input, which is split. So we put some input, for example, 1, 2, 3, 4, 5. Then we get 15 at the end. So our input, when it's split, becomes a split list of strings. So we have string 1, string 2, string 3. So for example, if we grab some of this, you see it's a list of strings. Then what we're saying is apply the int function to each of the strings, and then you have a map object that surrounds that. A map object is just a iterator that lets you do this functionality. So you might notice if we try to do something like this, and then we print L. Oh no, it's too big. It's not asking for input. Why? All right, we're going to have to skip that for now. But essentially, you can't create a list from map won't return you a list or whatever your type was before, it will return you an iterator. So you have to put your items back inside a list again. So for example, something like this. Okay, but for now we don't need to worry. Zip is another more useful function. It just aggregates multiple iterators into a tuple. So you might have something like this, right? And you get, oh no, something's not working. Technical difficulties. Okay. Cool. So what we're saying here is we're zipping the strings 1, 2, 3, 4, 5, 6, 7, 8, 9, and we're just taking one from each of them. So we take one from the first one from the second, one from the third one, and then we get a tuple which is 1, 4, 7. This is useful if you want to iterate over multiple things at some time. You might even have something like this, and so you can say, okay, I want A to be with 1, B to be with 2, and then zip by default will just stop at the earliest one.
How do you make it stop at the later one?
I'll show you later. Okay, so there's also a function called enumerate. This is really handy as well. What enumerate does is it goes through a list and it iterates through that list, and it returns the index that you're currently at and the item itself. And the way it does that is that it returns tuples of that thing. So for example, if we do print enumerate L, and we ask for some input, let's make this more clear. Then we have an enumerate object, because these objects are just things you have to iterate over. So then we have to convert it to something. Mr. Bracket. Cool. So you can see we get a list of tuples with A, B, 0A, 1B, etc. So you can tell you get something like this. This is useful if you want to iterate over part of an array, but also make sure keep track of where you were so you can do something with that number. For example, say you're iterating over every line in a file and you want to keep track of what line you're up to, then you can just wrap the file with enumerate, and then you print out the line and the line number. Does that make sense? All right. So the filter function returns an iterator, but only the things that are true. So in this case, we have a list of ints that we take. So 1, 2, 3, 4, 5. And what we're saying is we take in the filter, and our filter takes in a function and an iterable. So our function is a lambda function, and the iterable is just a list. And any of those items in the iterable that are even will then get returned into the iterator. What is a lambda function? A lambda function is just a one-line function. And so you define it by saying lambda, the item you want to pass in, and what you want to do with the item, and that's what will get returned. Okay. We also have max and min. So they will return whatever you want, depending on if you give it a iterable or a list of arguments. So for example, in here we'll give it a list of arguments or something to iterate over, and it gives us back the maximum, which is 6. And then here we just give it a bunch of arguments, and that just gives us 1. They can also take keyword arguments and what you want to return by default. So this is really useful if you want to, say, get the maximum value out of a dictionary. Instead of looping over every key in the dictionary, finding which item is the maximum, saving it, and then updating every time, you just call max on it with a key of being what you want. So something like this. You have a dictionary which maps A to 3, B to 2, and C to 1. If you call max on the dictionary, you get D by default. If you call max on the dictionary, you get D by default. But then, sorry, I have to print these. Cool. So you call max on the dictionary, you get C by default because C is the highest letter in that dictionary of the keys. But if you call max on the dictionary and say, I want you to key this based on the item, not the value, sorry, the value, not the key, then you can just do it with another lambda function. You just say, okay, I want to pass in the key, and then I pass the key into the dictionary itself, and then I compare by the values instead. Does that make sense? All right. Yeah?
And just use D.P
You can. Wait, d dot get x?
No, just they don't get it minus one.
All right.
Without the first.
No, we have to.
Oh, right.
So,
That's true. Cool. I forgot about that. Awesome. Better as we go. All right. All is a function that takes in an iterable and returns true if all of them are true. Simple, right? So we have a list which is true, true, false. This returns false because they're not all true. We have another function which is called any, returns true if any of them are true. So we have true, false, false. It's true, and so it returns true. Like the first one is true, so return true. This also note that this also works like any standard binary operations. So if you do like an if, this, and the first one is true, then you won't run the second one, right? You could easily put functions in here and just say, okay, run the first function, does this return true? If not, run the second function, and so forth. Oh no. All right, so this is handy if you want to do something like this, right? You say, okay, if L0 is true, and L1 is true, and L2 is true, then print all of L is true, right? What are you talking about? Oh, I haven't defined L. Oh well, we're not defining it now. Okay, you can just say, okay, just say if is all of L true, and then print true. All right, so that covers the basic functions. Anyone have any questions? Okay. So if you're quite new to Python, this is probably what will benefit you the most. This allows you to write for loops that are much more succinct and make, well, they're much more succinct, but also give you a better understanding of Python itself. And what list comprehensions do, or any comprehensions, is they take an iterable and just make a new X from them. So for example, we'll start off with lists. So they allow us to take any loop and convert them into shorter statements. For example, we have a list, and we have a for loop that does this. It goes through every item in the list which is reversed, and then appends a new item to a list, which is the power of itself, right? And so we get this new list at the end. This is easily 3 lines of code. Oh, and what we can do is we can use a list comprehension. And list comprehension looks like this. You start off with, well, let's not start off with that for now. If we just cover up the first part, so we just look at this, this is just a normal for loop. It just says for the element inside the iterable, right? And then the element you put at the front is the item that you want to append to that list. So like we had before, here, this item is the item we want to append, and this is our for loop. So we can easily just convert it to, man, we just defined L. What are you talking about? Cool. So we just do something like this. We say I to the power of I for every I in the list which is reversed. Does that make sense? Cool. So what if you had a for loop like this? We go through every item in L, and we check if it's even, and if it is even, then we append it to the list. And we append it times 2 to the list. We get something like this. But what we can do is we can convert it to something like this. We just say, okay, it's literally what we had before, except shifted around a bit. So we have, okay, the item we want to append for every item in the list if the item is even. Does that make sense? All right. What's really nice though is that you can break them up into lines like this. You can say, okay, I times 2 for I in L if it's even. And then when you read code like this, you can just easily go, okay, this new list is a list of elements which are doubled, taken from the list, which are even. This is much easier to read than having something before like this. You actually have to read into the for loop and say, okay, I see there's a new list being declared, we append elements to the list, and then we check if they're even. Not only that, but code like this is actually faster. So what if you wanted to make a 2D list, right? Well, we could have something like this, right? Which is, okay, the non-element times 3, and then that list times 3 again. And then what happens is, if we print the array, we get a list like this. But now we have a problem, right? Because say we want to change something in the array. Say we want to make the 0th element of in the first list, the second element, we want to make that equal to 1. And then we print the array again. Now we have 1 in every element. You can see how this is becoming a problem now. Because you think you've made a 2D array, but actually you've made an array of nuns, which is one reference, and then you've copied that reference 3 times to every other element in the list. 2D list comprehensions let us get around this. So say we have some code that looks like this, and so if we walk through it, it goes through from 0 to the size of the list to the power of 2, and then it has an inner array, and the inner array goes through every element plus 3, and then we append every element to the inner array, and once we're done, we append that array to the other array, and then you can kind of see where this is going, right? We run this, we just get a list of 0, 1, 2, 3, 4, 5, 6, 7, 8. What we can do instead is we can say, okay, just like before, where the item to append was at the top, we just put another list comprehension in there. And we say, the item to append is another list comprehension. And so we start off here and we say, okay, for every item in the range to this power, and then for every item in this range to this power, just make a new list from that. And it does that 3 times, and then we get a new array, which is exactly the same as before. Now, even code like this, you can still improve on, because you can say things like, okay, well, we don't need this 0, because by default, range will start from 0. And this list comprehension is actually useless, because we're just appending the same element over and over again, right? Instead, we should use what is actually made for this, which is you just pass the iterator into the list function, and you just make a direct list from that. This hasn't been defined. Why did that happen?
Your range, your second range, since you removed the 0, the step doesn't.
Oh, right. That's why it was there. Okay, thank you. I was wrong. All right. Sorry? Name parameters. You can, that's true. So this would be the end, and this would be the step. Doesn't take keyword arguments?
It just said
All right, well, I guess we're wrong, but it should. These are things you could like make a pep about and then say, can we do this? And people say, oh, maybe. Okay, so what about flattening a list? We have an array, and we just want to append every element to that array, right? What happened now? I think our L got redefined. What's the problem with writing Jupyter code? Oh, that's right, because, okay, let's go back. Cool. So now what we've done is we've said, okay, for every list in the array, go through that list and just add that element to that list, right? And now you have a new list with all the elements. What we can do with list comprehensions is just say, okay, add the element I to this list for every list in the array for every element in the list. Often online, you'll see these things as one line. And if you actually watch me put this into one line, how confusing does that look now? Right? Because now you have to stand, okay, wait, does this for loop go first or does this for loop go first? And in which order do these things happen? Once we've put them over new lines, this makes a lot more sense. Just say, okay, for every element, for every list in the array, for every I in the L. And the other benefit about this is that it looks exactly the same like the for loop we have above. We just copy it exactly as we have, and we get it as we have it. Sorry? Sum function. Why do we want to sum?
Because if you add lists, it will be cat.
No, you don't want to do that. Because, so what you're saying is you want to do something like for L in array, sum, and then, oh, right. I've never seen that before. Okay, so if this is summing like this, yes, so, okay, if we do this, if we're doing something like this, what's actually happening is we're copying the list every time. So it ends up being quadratic. Because you're copying the list and then you're remaking the list when you want to add something else to it. Because they're not like linked lists. I know what you're saying. I think, yeah, you have to check. The other thing you can do is dot extend. Dot extend will extend the list with that element in it, with an iterable. And this ends up being faster most of the times. Okay, so list comprehensions also apply to dictionaries. So you can have dictionary comprehensions. So you have something like ln for n in L, and then enumerate the letters A to E. So we print this and we got A equals 0, B equals 1, etc. You can also do it to sets. So you can say n to the power of 2 for every n in range 5. And now we have a set of all these numbers, right? But it's important to note that these comprehensions return the type themselves, unlike generators. And generators are lazy objects, which will return a value every time they are evaluated. So for example, we have a generator like this. And this is a very large number, right? This will make a list which is really big. But we can run it, right? We can say, okay, we've now saved this list into Python. But we can't actually make a list from that, because a list will have to go through the entire generator and actually save that list into memory. Here we're just saying there's a generator and it will return something for us. So for example, we have a generator which is 10 numbers. And what we can say is go through the generator 5 times. And it goes through 5 times. But what happens if we run it again? Now we go through the other 5 times, right? Because the generator will save where it's up to, and then every time you ask it for something, it will give you a new element back. So now if we do it again, it's turning us off. It's saying, there's no more for me to give you. I can't give you any more. The important thing to note about this is that a generator should only be used once. So go through it once and you get rid of it. It's not something you should save. But the nice thing is that we can put generators in a lot of places. So we can say, okay, pass in a generator into sorted, and then make a sorted list from that. And now we have this. But this is so common that they've actually implemented syntax for this just so you can have a generated expression without having the actual brackets. So we have a problem which is sum a list of numbers from input. We can start off by writing code which looks something like this, right? We go through every number. We start with a total which is equal to 0. And then we get the integer of that number and then add it to the total. Right? What we want to do is we want to end up with code that looks like this. So we have a list generator. Sorry, we have a list comprehension which makes it int for every element in the data that was split. Or the other way of doing it is just saying, sorry. So firstly, we convert our numbers into ints. And then all we have to do is just call the sum function. Because as the sum functions exist, we should use it. Okay.
In terms of generators, what other generators are there apart from range?
In terms of what?
Like in terms of a generator, something that generates inputs. I've only seen range. I've only ever used range.
Essentially, things like reversed range, there's another one.
Does reverse actually use the generator?
Yes, so reversed range map and other alike are all generators that are iterable, and they're only iterable once. Which is why you either use them once in a for loop, and you go through them all in once, or you convert them into a list for something you want to keep using later on. But you can also make your own generators, right? So we've seen how generators are used, but how do we make them? There's a yield keyword in Python, which basically you use like this. And now we've defined the generator, and yield will return whatever value it's given, and then freeze the state of that function. So we can loop through them like an iterator protocol. Something like this. We say for I in generator, print I. Or we can do it by calling next. For example, like this. And now we have print next G, next of G, and then we call next of G again. It says, okay, I can't do any more because I got to stop. So with this knowledge, we can write a Fibonacci generator. And so now we have something like this. We're saying A equals 0, B equals 1, while true, so keep running this loop, yield the value of A, and then A will become B, and B becomes A plus B. So now we run this, and now we can assign the generator to a value, and then we can keep calling next. So I can sit here and get the entire Fibonacci sequence up until infinity. And the thing that's nice about this is that it doesn't take up any memory. It's not saving the previous numbers. It's just getting you the next and the next and the next, right? And it goes to infinity. So you can't put a for loop in this. But the nice thing about this is that it's just on the go. And what you can do is you can just import iter-tools or any other iterator protocol that you want to use. And then you can just ask, for example, I want the first 10 elements of this generator, or I want the 11th element, or I want this certain range of elements. Yes?
If you want to reset it, you just call it without net. Or is there a command?
You'd have to, oh, I'm not sure.
You have to just create a new.
Yeah, you just create a new one. That would be the simplest way.
So you set the variable equal to, like, F equals
Yeah,
two, so
yeah.
You have to say like G equals two.
Yeah. And then you can have multiple instances of like the generator. So you can have one Fibonacci sequence, which is one number behind the other, or something like that. All right. Okay. So there's a lot of things to cover, but I want to cover this first. Okay. So we have the underscore idiom. The underscore idiom is just convention for saying, I don't care about this variable, let's just forget about it. So you can have something like this. If you want something to happen 3 times, you just use the underscore for the variable and it prints hello 3 times. Another useful thing you can do is breaking code over multiple lines. So you can use the slash for this. And so for example, if we try and run code like this, it will be a syntax error. What Python wants from you, I don't want line numbers. What Python wants from you is a slash. And the slash says, hold on, I still have more of this line to go. But it's not recommended to do this. And so what we can do instead is wrap our code in brackets. And we can say, okay, 1 and 2 and 3, print 4. And hopefully with this, you can start to indent your code a bit more nicely to have different ways of doing things. Forgot to ask, were there any questions regarding anything? All right. Another thing is ternary expressions. So you have something like, they're defined like this. The item that you want to return goes first, if that item is true. This is the item you want to check, and this is the item you want to return if it's false. So it's kind of backwards from C. Essentially, you read it and you say, the first thing is the item I want to return if my item is true. And the last thing is what I want to do otherwise. So you can have something like this. For every range, for every number from 0 to 4, then we go, okay, print odd if it's even. Sorry, print odd if it's odd, otherwise print even. And now we have something like this. Does that make sense? All right. Some really nice feature that is rarely used is something called extended slices. So you know how we can index lists and strings with slices and say I want the 5th to the 4th element? What you can also do is say delete certain parts of lists with slices or even assign to them. So we have a normal list here. And what we can do is say, okay, I want to print the elements from 3 to 6. So we've got elements 3 to 6. But now what I want to do is I want to assign some new elements to 3 to 6. So now when we print 3 to 6 again, we get x, y, 6. And now what we have is our original list has become 0, 1, 2, x, y, 6, 7, 8. Essentially, we've said we want to replace this part of our list with something else, with this iterable. This is handy if you want to like work in a 2D array and replace certain sections of it. Yep? Oh, right. So trailing column doesn't need to be there. In Python, it won't complain at you if the last element has a trailing comma. This is nice because, for example, say you're indenting like this. You can then shift these elements around without Python complaining that you forgot the trailing comma. Sorry? Yes, I didn't put that in. Since Matt has mentioned it. In Python, if you want a tuple, you have to do something like this. So the type of x becomes a tuple. However, if you want a one-element tuple, you can't do something like this, because then the brackets just disappear. What you instead have to do is say, add the comma, and this will make you a tuple for you. Another thing worth mentioning is that you can also delete slices as well. So you can say, okay, from 2 onwards, I want to make it nothing, or delete from 2 onwards, or from 2 behind. So now we've deleted the last part and the first part of the list. Yeah?
What's the point of a one column? Sorry? Sometimes they reply something.
Yeah.
They reply another column.
So
Usually you can pass down a list
for example, whenever you do an SQL call and you want to pass in arguments to SQL, it requires you pass in a tuple. If you only want to pass in one argument, a lot of people get stuck by that at first because it says, hold on, I just want to pass in one, why can't I do it? It's because you need a tuple, which is just one element. Yeah. So some methods actually take in tuples. For example, if we have code like this, which checks does this website start with HTTP or HTTPS, then it's a link. What we can do instead, or if we have some code like this, which is the instance of item a string, an int, or a tuple, then it's immutable, right? What instead we can do is pass tuples inside them and say, does it start with this or this? Then it's a link. Does it start with a string, an int, or a tuple? Then it's immutable. And this will help you condense your code base and make it much easier to read as well. One rarely seen feature of Python is the ellipsis. Ellipsis is just an object which you can use to extend functionality of code. So the type of ... is ellipsis. The other thing you can do with it is nop your function. So you can define a function and say, I don't want it to do anything. You can use ... or you can even use pass. So what I mean by this is when you're writing class-oriented code and you have something like they ask you for a certain item in the list, you can specify it so that if they ask for ellipsis, you can give them back everything or something along those lines. This is what NumPy does. One of the nicest things about Python is unpacking. So tuple unpacking and swapping. Tuple unpacking lets us easily assign variables. So doing something like this. A equals 0, B equals 1, right? Print A and B comes out the same. It avoids us having to do something like this, which is, okay, we have a string.split and that's assigned to a list. And then we say, okay, if the first element of the list is not in the dictionary, do something. And then you can start to see how like all these brackets make the code really unreadable. Oh no, oh well. Or we can even have something like this. In our attempts to make the code nicer, we say, okay, assign our split list to L, and then the first item is the first item of the list, and the number is the second item of the list. And now we've replaced our code with variables, which is nicer, but it's not the full extent that you can take Python. What you can do is you can unpack the list into variables as you go. So you can say, okay, name takes the first name takes the first item, and number takes the second item, right? And now, when you have the list, you can say something like A1, B1, A2. It'll print you a dictionary like before, and it's much more readable in terms of what this does.
Why not use a default here?
This is just an example. I don't know. Yeah, we'll get to that later as well, if we have time. You can also throw away values we don't need, right? So say we have a list which splits into 3 elements, and we don't want the second element, say it's like a colon or something, then we just put it in the underscore variable and we just don't never use it, yeah?
If it's multiple variables, then can we use underscore variable twice?
You mean something like this? Yeah, it's fine. The other thing that's worth noting is that if we put in, oh, I screwed up. Let's get back. Did the code just disappear? I accidentally deleted it. Okay, well then. What I was going to say is, if split takes in, oh wait, the code is actually here, except it's not. Can I convert it, please? No, okay. Oh, that's because it's a comment. No? Anyway, So split will sometimes return more than 4 arguments. What you want to do in that case is say how many times you want to like the maximum times you want to split. Any questions? All right. So remember before how we swapped two variables? Remember how you would swap variables in a language like C? We say, okay, A equals 0, B equals 1. Then we assign B to temp, and then we assign B to A, and etc. Right? What we can do now is use tuple unpacking instead and say, okay, A and B is 0 and 1. Now what we can do is say, okay, A equals B and B equals A. And this will work on the go, and we won't need this temp business. It will just work as it is. The other nice thing we can do is packing iterables into a list. So, for example, we have a list, which isn't working because I did something bad before. Jupyter's so good, sometimes. Oh no. Maybe at the end of this talk, you can feel like a better Python programmer and then go fix Jupyter. So we're up to this. Okay. So we make a list, which is, right? And then what we can say is, okay, I want the first element on the list to be A, the second element on the list to be B, and every other element to be C. And now we have 1, 2, and a list which is 3, 4, 5, right? We can even say I want the first elements to be this, and everything else, everything but the last 2 elements in the first part, and so forth. Or you can even define the middle. And you have something like this.
For C, what happens if you don't have the asterisks for C?
For this one.
No, for number 3.
All right, this is what I was trying to show you before. It will tell you there's too many values to unpack. So you have to say you want to like throw away everything. You can do something like this. I don't care about anything else, essentially. All right. The other nice thing about Python is that it has support for a lot of function argument stuff. So you can define positional, default or optional, and keyword arguments. So for example, we're going to make a function called write, and it takes in an item, and it also has a default argument of new line, which is for end. Sorry, a default argument called end, which has a new line. So now our write function returns the item and then the end at the end of it. So now what we can do is we can call this function with something. Yes, that is true. And then it returns something like this. But then we can pass in what the end should be, and then it returns that as well. So this is useful, like when you use print, this happens. There's one problem though with this, which is you can't specify immutable as a default argument, because what ends up happening is the function gets instantiated with that default argument, and so every call of that function will use that same variable. So, for example, do I have code for this? Yes, okay. So this function has a default argument, which is a list, and all it does is append item to that list if the list is there. Okay. Now we have something like this, and you can see, because it uses the same instance every time, it's adding to the same list. The way we fix this is we default it to none, and if it's initiated as none, we initiate it in the function itself. You can also specify an arbitrary number of arguments. I have 12 minutes, right? just in case. So in this function, we're saying take in the start and then take in a multiple number of items, right? And so what happens here is we're saying, okay, this function starts with something and then joins all the other arguments given to it and then just prints the end. So you have something like this. We haven't defined it. We have something like this. It's just A, B, and then C. If we add in some more arguments, it will just keep going, right? This is really handy if you want to just pass your argument a iterable, right? Or you want to do something like the print function, for example. Okay. Right. It's worth noting, though, that how this process works. First, positional arguments are taken. Then all the arbitrary arguments are taken. And then any arguments that are required will become... no, hold on, yes. So first, it's all the positional arguments that will work as normal. And then all the arbitrary arguments will follow after. You can also specify keyword arguments. So you can say, okay, I want to take in a bunch of keywords. Essentially, I want to take in a dictionary. And I want to join that dictionary with the keyword and its value for every item in the keywords, right? Now that we have this function, we've got this call, and we're saying, okay, the separator is a dash, but a name, which hasn't been defined up here, is Evan. And now we can say, okay, print ABC, and then name : Evan. The handy thing about this is a user can specify something like as list equals hello or something, and then you can check for that argument and say, does this argument exist? If it does, let me check what the value of it is. You can also do unpacking with star and double star. So the star operator will let us unpack or expand values into function arguments. So we have a list here. And now what we can do is we can say, I want to pass in the list into the right function. But what I want to do is I want to unpack all those arguments in list, all those elements in list into the arguments of the function. And now we get something like this. Does that make sense? A handy thing about this is, say we want to print out a list separated by spaces. Well, we could do space.join L and then pass a list to and then pass a string which is separated by spaces to a function. Or we can even say something like, I want to unpack every item in L into the print function. And the print function will take a multiple amounts of arguments and just separate it by spaces for us. The double star operator will also let us unpack a dictionary as keywords into a function. So you have something like this. And we can just give that to our right function with double star, and then it works as we'd like. Okay. Unlike C, which means you have to do something like this, Python will let you do something like this, which means, okay, you got 1, 2, 3, X, Y, Z, and instead of having to evaluate what Y is twice, this is valid code that will check, is Y bigger than X, and is Y smaller than Z? Is there people waiting outside? I think so. Vivian, are there people waiting? Is this booked? Oh, are they? Sorry? At 3, okay. We better finish this up. Okay. The with statement lets you open a file and close it once you're outside of that indent. And what you can also do is do the same thing with an SQL database. It will auto close it. It will auto save once you've executed something. There's a lot of exceptions you can do, but for example, we can try something, and if that something works, then we raise that error. Actually, let's just not do this. Okay, the final thing that is really awesome is for while else. For loops and while loops have else statements. And what that means is run the else code if the function wasn't broken. So another way of saying this is, if I haven't finished the loop, keep doing the body. And else, if I have finished the body, is there anything else I need to do? So you can have code that looks something like this. You go through every element in the list, right? And then once you've gone through every element, do the last element. So this works if we want to do something like not print a trailing space. Okay. The most handy thing about this is code that requires flags. So in this code, we have to have found equals false, and then change it once we break. What we can do instead is just do that thing we want to do afterwards, after we've, if the code hasn't broken. And that's about it. Okay, I've written other slides with more things in it. I'll upload those later and put a link to Facebook. Thank you for coming.